So why does rate even matter? We're going to be looking at rate this chapter. And so it's kind of a question, why does it matter? Why are we even looking at this? Why does it help us to know that a reaction occurs at a certain speed when you use certain concentrations? Well, if you think about the body and the processes that are going on in the body, some of those processes need to happen in certain time frames. For example, if you need insulin, you need those insulin reactions to happen at an exact time frame when the sugar has peaked beyond what the body's controlling. Or if you look at digestion, you need the digestion to occur in such a way that it doesn't cause any kind of damage to other parts of the digestion tract by being too slow or too fast. Other things that matter in the body, like there's even heart rate. So the heart rate needs to occur at a certain speed for a certain body size. These are all things that really do matter and that keep people alive. So one reason that we look at chemical rates has to do with basically keeping people alive. And so in the industry, in the medical industry, reaction speeds and reaction rates, again, it helps us keep people alive. If you jump into industry and you begin looking at industry, if you're looking at like chemical plants, what chemical plants do is they scale up reactions. And this also ties back into keeping people alive because they need to know if they scale up reaction, 500,000 times what you might do in the lab. Is it going to create a reaction that's uncontrollable or that's too hot or that people could get injured trying to handle, that could mess up the equipment, that's beyond equipment ratings? So there's that aspect of it, but there's also the time is money aspect of it. And so if you know that a reaction might be able to take place in just a few minutes and a similar reaction that makes the same product will take, a few days, well, then you're going to be going with the one that takes a few minutes. So all of these are good, strong reasons for knowing general reaction rates of reactions. And in chemistry, we like making these tables of values, and we're like, oh yeah, so every reaction that we know of, here's the rate. It doesn't exactly work that way, but you can look up the rate of quite a few standard reactions. Basically, once a reaction becomes important and we have a good use for it, you can start finding data about it. So again, we've mentioned chemical plants and medicine. And so reaction rate has a general format, and this is the format that we're using for a reaction rate. So, and of course, it doesn't matter if you write the rate on the left or the right, and if you go and watch other YouTube videos, you might see it on different sides. But we always write reaction rate, and note that like on the road, we're talking about distance per time. But in this case, we're talking about like concentration change per time. Like your reactants are getting less, basically. How long does it take for your reactants to get close to zero? And how fast does it happen? Like in 1 minute, can a lot of them go? Or is there just a little bit that goes in 1 minute? Like those are the kinds of questions we're talking about when we're talking about rates. So we're talking about concentration change per amount of time. And we actually are only looking at reactants when we do these. So in this with this format, if I had this kind of a rate, it would have an A plus a B kind of a look to it for the reaction. We don't care about what the products are for rate because we have to measure something. And so we're just going to measure not how fast products appear, but we're measuring how fast reactants disappear. That's how we measure it. We have these little things that are higher, the M and the N. Those are the exponents, and this is the order. And when I just have it outside the A, it's the order with respect to A. And then this one is the order with respect to B. And the key thing is actually that we also need to know the overall order, because overall reactions that are first order do different kinds of things in reaction that are second and then third. So the overall order is you just add up all the exponents and you'll have a final thing. Last bit is that when we look at this, we have a K factor. So this is a constant, but it's not the kind of constant where you can go grab it off a chart and it's always the same. This is unique to the reaction. So what we find with all reactions is that we can write a rate law, and it looks like this kind of a format. You can even have like C's and D's if they are reactants. You can have extra things in it, but it has this kind of a format, and that our K value is unique to that reaction. So it kind of helps us kind of standardize what we talk. I don't know. Some people think of it as like K is like the fudge factor or whatever, but it's the factor that makes the rate law unique to any reaction. So you'll sometimes find us asking for the K value, and then sometimes you'll just have us, we'll just write in and the K, and we just put it in there as K. So you'll have to pay attention to the reactions for how it works.